Hello, and welcome to our tutorial on Introduction to Cisco Unified Communications. My name is Milton Moore, and I am Principal Consultant with IP Consulting, Inc. Our agenda will begin by defining unified communications, then we'll have a discussion about telephony in general. We'll move on to identifying key components of a Cisco Unified Communications solutions. I will then discuss Microsoft and Cisco integration. Finally, we'll have a short wrap-up. One definition that I've come across is an evolving communication technology architecture which automates and unifies all forms of human and device communications in context and with a common experience. Its purpose is to optimize business processes and enhance human communications by reducing latency, managing flows, and eliminating device and media dependencies. Well, that's certainly a mouthful. To help simplify the definition, here is what I'd like to propose. Technology that helps people more efficiently communicate and access the information they need quickly. With a UC solution, you can take an individual's desk phone, cell phone, email, computer, and allow them to act together to help facilitate communications regardless of location. Here's a diagram of a standard phone system. The brains of the solution is the Private Branch Exchange, PBX, or key system. The PBX performs the following functions: call routing, switching, and trunk termination to the public switch telephone network, PSTN. The analog or digital phones are directly connected to the PBX via dedicated wiring. Each phone is assigned an extension and can dial other internal extensions. For example, if extension 2001 wanted to dial extension 2003, it would only have to use 4 digits. Typically, to call an outside number, a user would use an access code like 9. In that case, the dialed number would be 9555124. When comparing a standard PBX and Cisco IP telephony, we can see that all the functions are there. Instead of one large box, a Cisco IP telephony solution is more distributed. The call processing is performed by a server running Cisco Unified Communications Manager software. Switching is done by the Cisco Catalyst data switches, and trunk termination is done on Cisco Integrated Services routers. This design makes it easier to lower implementation costs and increase redundancy by converging both data and voice networks onto a single infrastructure. Here are the key features for IP telephony. Call processing. Call routing is the process of deciding what is the most efficient way to send calls to their destination. This would include sending a call to a remote office over the data network instead of making a long-distance call. Dial plan configuration is specifying what numbers can be reached from a particular device. It also determines what numbers can be dialed from the system. Device tracking. IP phones register with Communication Manager using a unique Media Access Control or MAC address. All phone configuration is tied to the MAC address. When a phone registers with Communication Manager, it downloads the configuration information and provides its current IP address. When a call is placed to that phone, Communication Manager does the extension to IP address resolution. In a converted environment, data switches should have a couple of extra features. One is support for Power over Ethernet, and the other is support for Quality of Service or QoS. Power over Ethernet is an IEEE standard for sending electrical power over standard data cabling. Besides IP phones, PoE switches can power wireless access points, IP video cameras, and a host of other devices. Quality of service is a feature that allows network devices to differentiate traffic and treat them appropriately. For example, a switch running QoS can tell the difference between a voice conversation and a regular file transfer. Based on its configuration, the device can guarantee that the voice traffic has priority on the network. Under the voice gateway category, the keys are PSTN connectivity. The Cisco ISR routers support many different voice ports and densities. And quality of service. In a design where you have remote offices, the voice gateway can also act as the wide area network access device. It is crucial to perform QoS over the low bandwidth links. In this network diagram, you can see what a converged network looks like. Note the single infrastructure. Voice is now running on the data network. The computers are connected to the IP phones, which have switch ports on the back, so there's no need to install extra cables. The PoE switches are providing power to the IP phones and access points. The 2811 is the voice gateway to the PSTN.